This is a hyperbola with the branches opening to the left, and to the right. And the points here, these are called the foci. So this is focus number one, this is focus number two. And this is called the vertex number one, vertex number two. And this is the center of the ellipse. So the way the branches or the points on the hyperbola, the way they generate it is first pick any 2 points, call them F1, F2 for focus number one, focus number two. And so in this case, we picked for F1 to be at the point 50 and negative 50. And so the distance between F1 and F2 is 10. So one more time, first pick any 2 foci and make sure they're horizontally aligned. And then look at the distance between the 2 foci, in this case is 10. And then next, pick the constant less than 10. And for this particular example, we let the constant, call it D. The constant D is 4. And so what that means is this. Any point that's on the hyperbola, so let's take this point right here. The distance between point A and focus number 2, and then the distance between point A and focus number 1, the difference must be 4. So the length of this segment minus the length of this segment must be 4. So let's take this point C here. The length between C and F1 minus the length between C and F2 must be 4. And then same thing here, if we look at this point, then the distance from this point to F1 and the distance from this point to F2, then the difference between the two lengths must be 4. And so any point that's on the hyperbola, the distance from that point to F1 and then the distance from that point to F2, the difference between the two lengths must be the constant 4. So that's how the points are generated on the hyperbola. And for this type of the hyperbola with the branches opening to the left and then to the right, and then if we go through all the steps and work them out, the equation comes out to be like this. Well, H and K, that's the center of the hyperbola. And then A is the distance from center to vertex. So it's the distance from here to here. So for this particular example, the A here will be 2. And then C is the distance from the center to the focus. So in this case, it would be 5. And then B is the distance from center to M1. And then the relationship between ABC this time is A squared plus B squared equal to C squared. And so for the hyperbola, C is the longest. And then for the ellipse, A is the longest. But for the hyperbola, C is the longest. And then these two vertices, they're located at H minus A, comma K, H plus A, comma K. And then the 2 foci, they're located at H minus C, comma K, and H plus C, comma K. And then we also have the type of hyperbola where the branches, instead of opening left and right, these 2 branches here, they open up and then open down. And again, if we go through all the steps and work out the equation comes out to be like this. It'd be y minus k squared divided by a squared minus x minus h squared divided by b squared equal to 1. And so the question now is, what's the difference between this equation with the equation that have branches opening left and right? And so let's look at them so we can see the difference. So this equation is for branches left and right. And this equation is for branches up and down. So if the hyperbola has left and right branches, then it's going to be x first and then minus y. But for branches up and down, it'd be y minus x. So that's the order. So one more time, with the hyperbola have branches left and right, the x comes before the y. X minus y. But if we have branches up and down, it'd be y minus x. So that's how we know. And so we look at this example right here. We have x squared over 16 minus y minus 4 squared divided by 25. This time the order is x minus y. And therefore we have a hyperbola with branches to the left and right. And once again, how do we know that? Because it's x minus y. X comes before the y. So that's how we know this is the branches opening left and right. And in fact, if we graph this on the graphing calculator, then this is what the hyperbola looks like. So these are the branches right here. And then these two diagonals, they call asymptotes. Asymptotes. So now that we know the branches open to the left and right, then we would use this set of formulas to find the vertices and the foci. And so the equation would be of this type. And then we can modify this equation right here a little bit so that it looks like the standard form here. So this could be written as x minus 0. So now we have h is 0 and k is 4. And then to get the a and the b, the first number right here, that's going to be a squared. And then the second number, that will be b squared. So when the hyperbola is in standard form like this, the first number is always be a squared, and then the second denominator here is always going to be b squared. And recall that for the ellipse, the larger of the two is a squared. But for the hyperbola in standard form, the first number is a squared, and then the second denominator is b squared. And so for hyperbola in standard form, first denominator is a squared. So in this case, we have a squared is 16 and b squared is 25. And then right here, take the square root of both sides. Then we get a is 4. And then same thing here, take the square root. Then we get b is 5. And then to get c is the distance from center to focus. And then we have a squared plus b squared equal to c squared. And then note for hyperbola c is the longest. So we're always going to have c greater than a and c greater than b. Now for the ellipse, the longest length is the a length is a, but for the hyperbola, the longest is c. And so now we have a squared is 16, and then plus b squared is 25, and then equal to c squared. So we have c squared equal to 41. And then take the square root of both sides, and so we get c is equal to the square root of 41. So now we can get the vertices right here. H is 0, and then minus a, 8 is 4, and k is 4. So we get 0 plus 4 and 4. So this becomes negative 4, and this becomes 4. And then for the foci, again h is 0, and then c is the square root of 41. And then k is 4. And then over here we have 0 plus the square root of 41, 4. And then the equation of the asymptotes. Once again, this line right here, this is called the asymptotes. These two diagonals right here. So for this particular case, the a would be 8 is 4, and then b is 5. And so we have if we go 4 here and then 5 up here, and then if we can draw the rectangle, then that's called the principal rectangle. So 8 is 4, and then b is 5. So from the center we go 4 here and then 5 here, and then draw the rectangle. This is called the principal rectangle. And then we can see that the slope of this asymptote is going to be 4 up, 5 up and 4 over. So the slope will be 5 over 4. Remember, slope is the rise over the run. So we would go up 5 and go over 4. And then the slope of this line is going to be rise 5 and then run to the left 4. So the slope with this diagonal will be negative 5, 4. And then notice that this line right here, it passes through the center. And in this case, the center is 0, 4. And so this line, it has the slope of 5, 4, and passes through the center 0, 4. And this diagonal has the slope of negative 5, 4. Okay, we go up 5 and left 4. And it passes through 0, 4. So the equations of the asymptotes as follows. And remember that the equation of a line is y minus y1 equal to the slope times x minus x1, where x1 and y1, that's the point that the line passes through. In this case, the point passes through the line passes through the center, and so the center will be h, k, and then the slope of the diagonal line here is to be the rise over the run. The rise is b, the run is a, and so that's how we get b over a. And so the positive 1 will be for this line, and then this diagonal will be negative. And so normally we would write this as plus or minus. And in this case, k is 4, h is 0, and then b is 5, and 8 is 4. So these are the equations of the asymptotes.